Hazard communication and the global harmonized system. Objectives. Demonstrate understanding of the hazard communication standard. Demonstrate understanding of chemical labeling requirements. Demonstrate understanding the proper use of safety data sheets. Demonstrate understanding of how to properly label chemicals. The hazard communication standard. Purpose of hazard communication. The purpose of the hazard communication standard is to ensure that the hazards of all chemicals produced or imported are evaluated, and that information concerning their hazard is transmitted to employers and employees. The global harmonized system. In 2012, OSHA updated the hazard communication standard to comply with the GHS system of classification and labeling of chemicals. It standardized labeling requirements. It changed the name of material safety data sheets to safety data sheets and standardized their format. Hazard communication requirements. Manufacturers. Chemical manufacturers must assess the hazards of their products. They must provide safety data sheets to customers, and ship the chemicals in properly labeled containers. Employers. Provide a written hazard communication program. Make SDS available to employees. Properly label chemicals. Train employees on HazCom. Maintain a hazardous chemical inventory. The right to know. Hazard communication is commonly referred to as the right to know. This law provides the right for employees to know the nature of the hazards they are exposed to. When hazard communication applies. The hazard communication standard applies to companies that have employees who are exposed to chemicals during normal work conditions, foreseeable emergencies. This includes liquids in containers, substances in pipes, welding and exhaust fumes, solids, gases, and vapors. HazCom applies to just about every business. Even common household cleaners are covered under this regulation. Hazard Communication Coordinator. The HazCom coordinator is responsible for identifying hazardous chemicals, preparing and implementing the written program, making sure containers are properly labeled, maintaining safety data sheets, provide or coordinate hazard communication training. Common chemical cleaners do not require safety data sheets. Understanding chemical hazards. Part 2. Understanding the methods of exposure to hazardous chemicals and how they affect your health. Routes of exposure. Inhalation, ingestion, absorption, injection. Inhalation. Inhalation is the most common form of chemical exposure. Many workers do not realize that they are inhaling hazardous chemicals. Some chemicals, such as carbon monoxide, can be very difficult to detect. Ingestion. Workers tend to ingest chemicals when they get it on their hands or clothing, and then put their hands near their mouth. Smoking, eating, drinking, and applying makeup are common examples of causes of chemical ingestion. Absorption. Absorption can occur when chemicals come in direct contact with the skin. If you look at a safety data sheet, you will see that protective gloves are required for nearly every chemical used. Injection. Injection can occur from sharp objects such as needles or cutting tools. High-pressure air and fluid systems can also cause injection exposure. Types of chemical hazards. Physical. A chemical has a physical hazard if it is any of the following: a combustible liquid, a compressed gas, explosive, flammable, and organic peroxide. Types of chemical hazards. Physical. A chemical has a physical hazard if it is any of the following: an oxidizer, pyrophoric, unstable reactive, water reactive. Types of chemical hazards. Health. A chemical has a health hazard if acute or chronic health effects may occur as a result of exposure. This includes carcinogens, toxic or highly toxic agents, reproductive toxins, irritants, corrosives, sensitizers, hepatotoxins, nephrotoxins, neurotoxins, agents that damage the hematopoietic system, or lungs, skin, eyes, or mucous membranes. Target organ effects. Hepatotoxins target the liver. Nephrotoxins target the kidneys. Neurotoxins target the nervous system. Reproductive toxins target the reproductive system. Types of exposure effects. Acute. Acute effects from exposure happen immediately. Vomiting, burning, and coughing are all examples of acute exposure effects. Chronic. Chronic effects happen over a long period of time, and are often more difficult to detect. Cancer, emphysema, and hearing loss are examples of chronic effects. Discussion. What types of exposure effects do you think are more hazardous, physical or health? Dose and response. Dose is the amount of the chemical the employee was exposed to. Response is how the body reacts to the chemical. The permissible exposure limit, PEL, from the SDS will tell you what exposure levels OSHA allows. The permissible exposure limit, PEL. The PEL is the allowable exposure limit established by OSHA. These PELs have not been updated since they were created over 50 years ago. Some of them may be dangerously out of date. The permissible exposure limit, PEL. Toluene is a chemical commonly found in paint thinners. The OSHA PEL is a time-weighted average of 200 ppm. The current American Conference of Governmental Industrial Hygienists, ACGA, recommends a limit of 20 ppm. The current recommends safe exposure to toluene is 10 times lower than the OSHA PEL. Always check the safety data sheet. Chemical inventory. Part 3, Maintaining an inventory of hazardous chemicals. Chemical inventory. The employer must maintain an accurate list of all the hazardous chemicals in the workplace. This list must reference the product identifier on the safety data sheet. Chemical inventory. The list can include the entire workplace, or it can be broken down by work area. A copy of the list must be kept with the written hazard communication program. Chemical inventory. Keep the list up to date. It should be integrated into part of the process of receiving chemicals into the workplace. An inaccurate chemical inventory is a commonly cited OSHA violation. Safety data sheets. Part 4, Providing information on chemical hazards. Safety data sheets. Safety data sheets, SDSs, provide the information and precautions required to work with a chemical safely. Every chemical must have a safety data sheet. Safety data sheet access. Employees must have immediate access to the relevant safety data sheets for their work area. They can be in a binder, included in work procedures, or electronic, as long as they have ready access. Safety data sheet contents. Identification. Hazards identification. Composition/information on ingredients. First aid measures. Firefighting measures. Accidental release measures. Handling and storage. Exposure control/personal protection. Physical and chemical properties. Stability and reactivity. Toxicological information. Ecological information. Disposal considerations. Transport information. Regulatory information. Other information. Section 1, Identification. The product identifier used on the label. Other names used. Recommended use of the chemical. Restrictions on use. Contact info for responsible party. Emergency contact number. Section 2, Hazards identification. Chemical classification. Signal word. Hazard statement. Precautionary statements. Unclassified hazards. Explanation of unknown acute toxicity. Section 3, Composition of ingredients. Chemical name. Common name and synonyms. CA number and other identifiers. Mixture information. Section 4, First aid measures. First aid measures. Symptoms and effects of exposure. Description, medical attention and special treatment needed, if necessary. Section 5, Firefighting measures. Suitable extinguishing agents. Hazards from a chemical fire. Special PPE for firefighters. Section 6, Accidental release measures. Precautions, protective equipment, and emergency procedures for handling a spill. Methods and materials for containment and cleaning up. Section 7, Handling and storage. Precautions for safe handling. Conditions for safe storage. Incompatible materials. Section 8, Exposure controls and personal protection. exposure limits, appropriate engineering controls, individual protection measures, such as PPE. Section 9, Physical and Chemical Properties. The properties of the chemical. This may include appearance, odor, pH, flash point, flammability, solubility, viscosity, plus more. Section 10, Stability and Reactivity. Reactivity. Chemical stability. Possibility of hazardous reactions. Conditions to avoid. Incompatible materials. Hazardous decomposition. Section 11, Toxicological information. Description of toxic health effects. Symptoms related to toxic characteristics. Delayed and immediate effects from exposure. Measures of toxicity, if it is a carcinogen. Section 12, Ecological information. Ecotoxicity. Persistence and degradability. Mobility in soil. Other adverse effects. Section 13, Disposal considerations. Description of waste residues. Safety handling and methods of disposal. Disposal of contaminated packaging. Section 14, Transport information. UN number. UN shipping name. Transport hazard class. Environmental hazards. Special precautions. Section 15, Regulatory information. Safety, health, and environmental regulations for the product. Section 16, Other information. The date of the preparation of the SDS or the most recent revision. Know your SDS. You should be familiar with the SDS for every chemical you work with. After the exposure accident is too late. You should know the hazards, engineering controls, required PPE, first aid requirements, and how to handle a spill. Review question. Where are the safety data sheets kept in your work area? Labeling requirements. Part 5, Proper labeling of chemicals in the workplace. Shipping labels. Chemical shipping labels must include the product identifier, the signal word, danger or warning, hazard statements, the appropriate pictograms, precautionary statements, name, address, and telephone number of the responsible party. The Global Harmonized Standard Pictograms. There are 9 pictograms that describe the potential chemical hazards. The relevant pictograms must be included on the label of every shipping container. The Global Harmonized Standard Pictograms. There are 9 pictograms that describe the potential chemical hazards. The relevant pictograms must be included on the label of every shipping container. Labeling requirements for chemical containers in the workplace. There are 2 options for labeling chemical containers in the workplace. Use the information contained on the shipping label. The product identifier and words, pictures, symbols, or a combination which provide information regarding the hazards of the chemicals. Labeling requirements for chemical containers in the workplace. The hazard warning on the label may be in words, symbols, or a combination of the three. It must provide employees with specific information regarding physical and health hazards of the chemical. Portable containers. Portable container are containers that have chemicals that were transferred from a labeled container, and they have been in the direct control of the person who performed the transfer. Portable containers are not required to be labeled. As soon as a portable container is out of the control of the person who performed the transfer, it becomes a secondary container, and labeling requirements apply. NFPA labels. NFPA labels are for firefighting and emergency response. They do not meet the requirements for chemical labeling in the workplace. Container labeling summary. Shipping container, the container the chemical is shipped in. Secondary container, the workplace container that stores the chemical. Portable container, the container the chemical is transferred to for performing work. Review question. What happens when a person sets down a portable container and walks away? How do requirements change? Hazard communication training requirements. Part 6. Informing employees of chemical hazards. Hazardous chemical information. Employees must be informed of the requirements of the Hazard Communication Standard, any operations in the work area where hazardous chemicals are present, the location and availability of the company hazard communication program, the list of hazardous chemicals, and the safety data sheets. Hazard communication training. Employees must be trained on methods and observations used to detect the presence or release of hazardous chemicals, the hazards of chemicals in the work area, the measures employees must take to protect themselves from the hazards, details of the hazard communication program, including the labeling system, safety data sheets, and how workers can obtain hazard information. Hazard communication training. Training must be conducted at the time of initial work assignment, when a new chemical hazard is introduced to the work area. Company hazard communication program. Documenting company policies on communicating chemical hazards. Hazard communication program. A lack of a written hazard communication program is the most frequently cited violation by OSHA. The hazard communication program contains the policies for communicating chemical hazards and safety precautions to employees. HazCom program contents. The policies for chemical labeling. The method and location for storing safety data sheets. Employee information and training. A list of hazardous chemicals present. The methods for communicating hazardous non-routine tasks. Communicating hazards of chemicals in unlabeled pipes. Summary and questions. Hazard communication summary. Hazard communication is the method that employers communicate the chemical hazards of the workplace to employees. Every chemical in the workplace must be properly labeled. Safety data sheets are required for every chemical and must be readily available to employees. Employees must be trained on chemical hazards and the methods for protecting themselves from the hazards. Every company must have a written hazard communication program.